Welcome to One Chemistry. In this video, we are going to see Pinacol Pinacolone rearrangement. It is a very important rearrangement. We discuss mechanism, basics behind the rearrangement. Stay tuned. Before we getting into the rearrangement, I given a quick reference. The rearrangement, the reaction, product, cation stability order, priority during the rearrangement, and OH reactivity, migrating ability, and leaving group position. This will be the quick references for you. It will help you to solve the problem. First, let us see what is Pinacol Pinacolone rearrangement. The names come from two alcoholic group. Product is with ketone. So 2OH group converted into ketone. Diol mean it connected with 4 alkyl group or aryl group. Finally you end up with ketone. One side with rearranged product, another side with similar product. Here the migration happen. Aryl or alkyl migrates. Mostly electron-rich group migrates. The intermediate is cation. Always stable cation form. If reaction happen in cyclohexane system, trans group migrates. The migrating ability from more dense hydrogen to primary alkyl group. We will see that migrating ability shortly. First you know what is rearrangement. Mechanism. Here acidic condition mostly you are using. You can use either Lewis base or Arrhenius base. Here I am using H+. H+ attack OH, make OH as a leaving group as H2O. Then cation forms. Some cases cation absorb, some cases don't. So cation form. To quench the cation, only pathway is OH to CO. What really happened? Phenyl migrates in this case. Cation form near the alcohol. Cation can be quenched as ketone by hydrogen elimination. So you end up with ketone here. Here driving force for the rearrangement is charge quenching because charges are unstable. Here to quench the cation, group migrates, quenched as ketone. Simple mechanism all around the basics. Here sometime asymmetric system will be there. Both alcoholic group determine which group migrates. Mostly you decide it by cation stability. You remove both the OH individually. You find the which one is more stable. Then decide it. Here I given two asymmetric alcohol. One is with phenyl, another with hydrogen. So what really happened? If you remove AOH and BOH, BOH if you remove, you have very less stable cation. If you remove AOH, more stable cation, so it is expected to be formed. So the final product decided by the cation stability. Since the cation is the center part, you should know the stability order. In simple term, tertiary is more stable, then secondary, then primary. Due to hyperconjugation, you can define it. But complete order would be cyclopropyl system can stabilize more because of position of p orbital. So first comes cyclopropyl system, then aryl system, then alkyl system. Finally you have methyl system. So cation order if you memorize, you can answer problems very quickly. Then second selectivity will be which group migrates. Normally the electron rich group migrates. Why? Because intermediate is cation. To quench the cation, you have to counteract with electron rich groups. Since cation is electron deficient, you counteract with electron rich groups. So electron rich group order will be hydrogen, phenyl and methyl. According to that, it will migrate. So simply hydrogen migrates first because of more electron density. Then the important thing, ring strain versus migrating ability. In some system, you have strain, while the cation formation, strain will be relieved. Strain means ring strain, Bayer strain. If it is 3 member, it will become 4 member. 4 member means 5 member, so on and so forth. One important thing is cation cannot form near the smaller ring because of S character. because of its geometry. It will be little advanced, but you know it won't form. Problems are best way to learn, so we'll learn more by solving the problems. Here you have diol with cyclic system, 2 cyclohexyl group, 2 alcohol, sulfuric acid you are using. You should find what will be the final product. We will go step by step and go by the basics. First will be abstraction of OH by H plus. H plus take the OH, form the cation. Then the cation has to be quenched. So ring expands to quench the cation. Cation form near the alcohol. During the transition, you have ring expansion. 6-member ring becomes 7-member ring. If you redraw nicely, you can clearly see it is a spiral system. Here cation form near the alcohol, so H eliminates, quenched as ketone. Here you should not worry about the migrating group because system is symmetrical, both sides same migrating group, you end up with same product. Then the next question, you have asymmetrical diol, one side with phenyl, another side with methyl, two alcoholic groups. You are using sulfuric acid. You should find what will be the final product. Here phenyl structure is hidden. If you redraw phenyl with ring, you can clearly see phenyl is the migrating group because it can assist the OH leaving by neighboring group participation. So OH is the H plus substract. Phenyl group assists the leaving and migrates. During the migration, cation form near the phenyl group. Then hydrogen eliminates. You end up as carbonyl. Then the next example, here you have asymmetrical system, one side phenyl, another side hydrogen, diol group is there, it is Pinacol. You are using sulfuric acid, you should find what will be the final product. As usual, we try to form stable cation. You can either remove A or B. A removal leads to the stable cation because phenyl can stabilize more. Further, migrating ability of hydrogen is better than phenyl, so no confusion. So the cation formed near the stabilizing phenyl group. Then migrating ability of hydride is better. It migrates. Cation formed near the alcohol. Then cation quenched as carbonyl by hydrogen elimination. Sometime you may wonder why hydrogen is migrating better than phenyl mean hydrogen is smaller, so dense. So comparatively it is very dense. So comparatively more electron rich when compared to phenyl. That's why it has higher mobility. Then the next example. Here you have asymmetrical pinacol. One alcoholic group has cyclohexyl, another one has cyclopentyl. You are using sulfuric acid. You should find what will be the final product. Here diol is there. You should form stable cation. As I said already, OH don't form near the smaller ring because smaller rings are more electronegative due to more S character. Because lower the hybridization, more the S character, so more electronegative. Here you have two possibility. One is near 5-member ring, another is near 6-member ring. Obviously near 6-member ring cation forms, then the cation expands, then to quench the cation, ring expands, 5-member ring becomes 6-member because strain can assist the reaction. Strain is relieved during the transition. Ring expands, you have cation near the alcohol. Then the cation quenched as carbonyl. If you redraw nicely, you have spirocyclohexyl system. Here you should learn the fact that cation never form near the smaller rings. Then interesting and final example, you have cyclohexyl system. 1-2 position you have alcohol, that is technically diol. One is with phenyl, another is hydrogen. Here two alcoholic groups are syn to each other. One is axial, one is equatorial. 1-2 position. You are using sulfuric acid. You should find what will be the final product? This problem is interesting because you have stereochemical problem here. Which alcohol moves? Here elimination is E2 elimination. For E2 elimination, you have anti-periplanar groups. OH will axial position will be best for transition. So axial OH is protonated, eliminated as H2O. You have cation. Then trans hydrogen migrates. It migrates. You have cation near the alcohol. Then cation quenched as ketone by carbonyl. So finally end up with ketone. Here migrating ability of hydrogen is better as well as it has anti-periplanar position. So the concept you have to learn here is alcohol elimination is E2 elimination. In cyclic system you have axial OH and axial migrating group is required.